application is through companies. Because even if you're in a hospital, if you give a patient a drug, it's a drug made by a company. If you give them a device, it's a device made by a company. And so where real application happens is in the biotech and pharmaceutical and medical device companies. Okay, so what we're trying to do is prepare our students for that. Okay, and so the direct clinical experience is one thing, but it's actually not the most efficient path to application.
Okay, am I right? Because I realized that half of your graduates are now in university. That doesn't mean that they are MIT, but half of them taking PhD or master courses at the moment.
Yes.
Yeah.
Yes.
Would you please comment also increasing number of humanities along the program, starting from one course and senior year?
And does it mean really one course or maybe many courses?
The students, and you can speak firsthand to this, I think bunch them in different ways. This is the total number that the institute requires for graduation, and some students double up, sometimes skip a semester, but you would be better able to
So
speak
for
to that.
example, if a student was really undecided in what they wanted to do, they can move all of these humanities into their second year. And so they'll spend their first year on GIRs, their second year on humanities and GIRs, and then they can move all of these classes down here, and they can satisfy all of their major classes in the second half. It's allowed, it's not encouraged, because that's really hard. In general, your major classes are your hardest classes, and so if you stack them all towards your junior and senior year, you're going to be very sad.
So Natalie, I would suggest, why don't you show them a bit about the two lab classes?
Yes.
Because that's very concrete.
Yes.
And then we can have time for Kristen to
That would
show
be
the
perfect.
biomedical engineering minor.
Can I take just
Sure.
two
Small
quick questions? Yes.
question. For instance, if 99% of the guys move the block to the end, would the teacher will teach the one person from the first block?
Never.
What's happening in
General
this case?
institute requirements
Yeah.
are everyone in all majors across all of MIT are taking these classes. So they're usually very large classes, probably the largest classes in MIT. So it's never the case that even if I, Tyler Hess, decide to take my biology course my fourth year, I'm taking it with all of the freshmen who are taking it their first year, some sophomores who are taking their sister, and very few juniors and seniors. So none of my friends are taking the class with me because they took it all their freshman year. But general institute requirements are always fall.
Is there another question? Okay. So let me, as Doug suggests, show you a little bit about the laboratory class that we run here. This is the first of the laboratory classes that we call Laboratory Fundamentals of Biological Engineering. All of the materials that we run our class from are on a open wiki, a world readable website called Open Wetware, and we run this laboratory class in the fall as well as in the spring with 3 experimental modules that are drawn directly from the research interests of the faculty. So in the fall, when I was spearheading the class, we had a DNA engineering module that came from the research in Bevan Engelward's lab, a professor here within our department. We have a systems engineering module, which is a synthetic biology module that I lead, and a biomaterials engineering module that comes directly from the work that Angela Belcher is doing in her lab. And so there is a constant revitalization of the laboratory curriculum that we are teaching the students. We always cover particular things that we think the students need to know in order to go on and do research in any of our labs within the department. So we always teach them tissue culture. We always teach them about proteins and about DNA, right? So there are important points that we always hit no matter what the experiment is. But what's really important about this class, I think, well, there are a number of important things. One is that it gives the students a real flavor for what biological engineering is. You can see that through their major here, the classes are quite general. And it is not always obvious to them what a biological engineer should do. Are they doctors who are better understanding the technology? Are they people developing the technology? Are they working in industry or consulting? So with this class, they get direct experience with biological engineering as it's happening in the department today, right? And so it's a very exciting class. It's a writing intensive class, so we teach them to communicate their work, we teach them to present their work. And it is also a resource intensive class, as you can imagine. We have people in the number of students within a single section is as small as 14 to 1 or 2 instructors. We have teaching assistants as well. But it is a class that we are very proud of, but it is a real challenge to run. The instrumentation class I don't have a wiki for, but it is the second of the laboratory classes that we run. It is just down the hall. It is a remarkable class where students who have never put a screw onto a nut, you know, are now building microscopes. They are building optical traps and tweezers and things that hold a bacteria by the flagella so they can count the rotations in it. And again, that class is very empowering for the students. It's very team-oriented. They learn a lot about each other, and they work directly with technology that then, if they go into industry as their direction, they are completely ready for. So maybe with that, I don't want to take too much of Chrissy's time to talk about the major, but that gives you sort of the broad strokes about the major, highlights 2 of the classes, the 2 laboratory classes a little bit, and I hope there'll be time at the end that we can answer sort of more general questions. Does that seem
Good, that's perfect, because I really want to show both programs just because of the distinctions, and your institutions may have one preference or another.
All right, so good morning. It is a pleasure to meet you. So as Doug mentioned, we have 2 choices for students regardless of what school they're in here, School of Engineering, School of Science, School of Management, and also outside of those schools, even the School of Architecture, and that's to do a major and to do a minor. Okay, so the major is, just as Natalie explained it, many course requirements that really build the foundation. And then the minor is something that a student wants to do often out of general interest, or that they want to explore a topic that's a little bit on the fringe of their comfort level. So this is a way for the student to explore and get some certification or accreditation that they've done enough to say that they know a little bit about this new area. So from the student's point of view, the minor can be very useful for their resume as they go out and seek jobs that are a little bit outside of their degree area. And then from the school's point of view, the minor actually helps us maintain a curriculum. So you'll see that here. So part of what we do as a service to the students is to make sure that the courses within the minor are offered every year so that they're always going to be available. So that's one of the things that actually takes a considerable amount of time from your point of view, okay, as you're running the program. So when I meet with the students, we meet with the students of the entire MIT campus twice a year to advertise our minor, and many other minor programs do the same. So I'm showing you some of what I discuss with them to explain what a minor is, and then also some slides that I put in just for you to explain how we run the minor here. So often they're interested in what do they do with this degree and how do they do it. And there's initially some confusion on their part because this is a biomedical engineering minor. And that means it's not the biological engineering minor. Okay? It's not the minor of this department, but it's a minor that this department runs as a service to the rest of the university. Okay? So that's in contrast to some of the other minors you might see at other schools. So there might be a minor in chemical engineering run by the chemical engineering department that also runs the major. But at MIT, these minor programs that are interdisciplinary are very common. So for example, there's a minor in energy. Okay, that's not run by one department, but one department or one committee has to take charge of it. Okay, so this is an interdisciplinary kind of approach. So we serve all of the students who don't major in our our department's major, which is biological engineering. So you could be in the business school and minor in this, you could be School of Architecture and minor in this, you could be in the School of Science and major in biology, but minor in biomedical engineering. Okay? And if you have any questions as you're making various minor programs, you can certainly email me for more information. So one of the students' main questions is, why should I do this? Why should I have even more restriction on my coursework? So you saw that they have a certain number of electives. I don't know how many that is. But now we're asking them to use those electives, a large chunk of them, for this minor. So what do they get out of that? So we explain that to them in terms of the ability to actually first have course offerings that lay it out for you. So let's say you as a student say, I want to know more about what biomedical engineering is. I've got this very large course catalog. What courses should I take? Right. So we lay it out for them. Here's many, many courses from which you can select. If you complete 8, that we specify different groups that I'll show you, then you've done enough to learn about biomedical engineering. So it's really an educational service to us, to them, that we lay out the coursework for them. And then what they do with that is very different from what a biological engineer would do, or what we would expect a biological engineer would do. So they're really applying engineering to medical problems. That's different from biological engineers, because biological engineers engineer biology to impact medicine, but also energy, a variety of fields, right? Not just medicine. But biomedical engineers focus on using engineering to achieve new solutions in medicine specifically. Okay, so for example, they could use the biomedical engineering degree or minor to actually work on medical imaging. So they use their knowledge of optics. Let's say they're an electrical engineer and they learn a lot of optics, and they want to say, how can I use those optics to make a new kind of medical imaging for cancer diagnosis? That's something a biomedical engineer would be thought of to do, or develop new hip implants, for example. But many of our minors go on to various other kinds of degrees. So let's say they major in electrical engineering and they minor in biomedical engineering. So now they've got 2 kinds of degrees. So we've seen these students go on in the years that we've run the program here to, for example, patent law, because now they have degrees that are very specified towards a specific area of patent law. We've seen them go to startup companies where they don't necessarily want to do the research, but they want to figure out where the research of that particular company should go. So what the research agenda should be, because they know engineering well, but they also know the biomedical engineering application space well. They can also go on to graduate school. We have a fair number who actually go on to medical school, as well as law school. So they want to be informed about the issues, the application areas, but they don't want to major in biomedical engineering. So this is the common track that we see. And then just so you can actually see at the course level what the curriculum is, and then I'll go into that in a little bit more detail and talk about how we plan that out. So we see over the past few years roughly 10 students who minor in this program per year. Okay, so about 40 to 50 students in the program at any given time. And given the size of MIT, that seems small. Okay, so why do we put in all this effort? So there's a reason why we do. So even though there's only 10 to 20 students per year, they're coming from several different departments: mechanical engineering, electrical engineering, material science and engineering, an increasing number from nuclear engineering because of medical imaging technologies, many from biology, and many from a department here, brain and cognitive science. But what's hidden here is how many majors are using the fact that we have the minor program to actually run their, what they call tracks, right? So biological engineering is its own discipline, it's well defined. But some of the older engineering majors at MIT, for example, chemical engineering, they're a huge major, right? Historically, they studied oil and petroleum engineering. So they've wanted to get into biomedical applications. How do they do that? They basically take the curriculum I'm about to show you, which is the curriculum for the minor, and they say to the students, if you do our chemical engineering major core, just like we have a biological engineering core, and you do the biomedical engineering minor, we'll give you a chemical engineering major